Hello, everyone.
Hello.
Yeah, as usual, please write down your full name into the chat area. That way I know who is here. Okay. All right, so how about your project one? Did you work on your project one, or did you finish your project one? Okay. All right, so if you haven't finished your project one, please, you can watch the video from last Thursday, or you can go to online, go to that project page, learn how to work on the project. Okay. Okay. So actually, from the project, we know that we're supposed to use Python for this course. Okay? For this class, actually, we use Python to write programs. So I want to use a week to give you a basic introduction about Python, how to use Python, what is Python, and how to use Python to write program. Actually, because every one of you already have the knowledge about the C++ programming, and also most of you, I know, you already know how to write programs using Java. So Python is another kind of programming language. I believe some of you already know how to write program using Python. So just want to make sure that you understand how to use Python to write programs. So this week I will use 2 class times to just go over the basic concept, basic idea about how to write programs using Python. Okay. In fact, Python is a kind of programming languages. It's the same as C++, C#, Fortran. All these are computer programming languages. Each of them, they have, C++, C#, Python, Fortran. These are all high-level language. When we say high-level language, means they are programming language, far from the low-level language, which are the machine code, assembly language. So high-level language, in fact, they are machine independent. That means they don't depend on the hardware. So that means, for example, if you write a C program, C++ program, or Python program for Windows, in fact, when you try to execute your programs, such kind of programs in another system, like or another hardware-based, Motorola-based computer system, you don't really need to rewrite your program. Actually, the only thing you need for Python, actually, you don't need to do anything. But for C++, you may need to recompile it, okay? But you don't need to rewrite the program, because these programs, they are programming language, they are machine independent. It's different from those low-level computer programming languages like machine code, assembly language. They are machine dependent, which means if you write a program for Intel microprocessor, if you wants to run that program in an ARM microprocessor, actually you cannot do that, because they are machine dependent. Okay, so but for Python, it's a kind of high-level language. So that means it's the same as C++. It's machine independent. So same as other programming languages, Python also, like I've said, is a kind of programming language. So that means it follows the same rules for other programming languages. Okay? So that means when you write a Python program, the code or source code, it means the sequence of instructions in a program. So for a program, it's a sequence of instructions. So each instruction is it's one line of the code. So the whole program, we call it a source code. And the syntax for programming language for Python is the same as other programming language. It's the set of legal structures and commands that can be used in a particular programming language. And output means the message is printed to the user by a program, because a program actually basically is a sequence of instructions. And the purpose for a program is to do something, is to process the data and then output the results. So those are basically the usage for writing programming language code. Okay? And another concept is the console. Okay? So console means the text box onto which output is printed. Okay? So in this example, the top window is the console. So when you run the program, actually the output message is printed out in this console box. Okay, so that's these are some basic concepts or terminologies for programming language. Okay. And for different programming language, we may have to deal differently. Okay. Some programming language we have to compile. Compile means if you want to execute, because you have to understand, a computer cannot, since we already know, from the previous introduction about Raspberry Pi, we already know that Raspberry Pi is a kind of computer. It's an embedded system computer. So personal computer, laptop, desktop, all these are computers. So a computer is just a digital device. Okay. So for digital device, that means the system can only understand two values, 1 and 2. 0 and 1. I'm sorry, 0 and 1. Okay. So those are the only two values a computer can understand. Okay. So that means if you want to execute a program and a computer can execute your program, you have to convert your program into a sequence of 0 and 1. Okay, so that's for machine code. Okay, so how can we? Because remember, when we write C++, we use ASCII code, right? We use like integer, we use float. Those are strings, and they are not in binary. So how can we convert a program into binary and let the computer run the program? There are two ways. Okay. For example, for C++, for Java, they use compilers. So the compilers means it's a program. Compiler is also a program, but this program is used to translate source code into binary, and then the binary can be executed by the hardware. Okay, so that means after you write your source code, you have to translate your source code to another binary code. So that means when you write a C++ program, if you want to run that C++ program, you have to create a new file. That means you translate your C++ source code into a binary code. You have to use a compiler to do this. Your compiler can convert your source code into a binary code, a binary file, and then you can run the binary file. Okay, so this is for compile. Another way we can execute a high-level language is using interpretation. Okay, that means you interpret. Okay, so like Python actually we don't have compile. We don't need to compile Python into a binary code. Okay, what we do, we only have a source code. Whenever we run the source code, we have to use a interpreter. The Python program actually provides an interpreter. So the interpreter will interpret your source code into machine code, and then the machine can run. But this machine code doesn't need to save somewhere. Okay, it's different from C++. C++, the binary code, the machine code has to be saved in a binary code file, and then you can only run the binary code file. Okay, the executable file. Okay, so this is different between C++ and Python. So Python, you don't have to compile it. You only need the source code. Whenever you want to run your source code, you use an interpreter to interpret it into binary code, into machine, binary sequences that machine can run. But for C++, you have to compile it. Okay, so that's the difference between these two kind of machine languages. All right, so for C++, let's see. The basic expressions, actually, you can see it's very similar to C++. So for, this is for Python, okay? So for Python, you can see, for example, if you want to do some very basic mathematical calculation, this actually, you can do like this, is 1 plus 4 times 3. And we know in math, multiplication has a higher priority order than addition. So that means, the computer will do this multiplication first and then plus 1. So the result will be 13, okay? And arithmetic operators for Python, actually, we have several kind of arithmetic operations. We have addition, subtraction, multiplication, and division. And this is called modulars. That means it gives the remainder as the result. Double stars is for the power, for the exponential, okay? And for the precedence, that means that the order in which operations are computed, like here we say a multiplication has a higher order comparing to addition. So you can see multiplication, division, modulus, and exponential, they have higher precedence than addition and subtraction. Okay? And if you want to do subtraction or addition first, you use parentheses. Okay? So it's very similar to arithmetic operations. In arithmetic operations, if you want to, we know, multiplication, division, they have a higher precedence compared to addition and subtraction. So if you want to do addition and subtraction first, you can use parentheses to force a certain order of evaluation. It's the same as in arithmetic operations. I mean, in C++ is the same also. Okay. And for integer division, in fact, in Python 2, this gives us integer division. So integer division means if you use 35 divided by 5, you got 7. That's an integer, okay? And if you use 84 divided by 10, it's 8. It's not 8.4. You see that? It's 8. So that's for integer division. In fact, in C++, we have the same thing. But this is only for Python 2. For Python 3, actually, if you just use a division sign, you will get if you do 84 over 10, you will have 8.4 instead. Okay. If you want to do integer division in Python 3, you have to use this double division symbol. Okay. So I can show you. Let me see. Okay, so in this case, this is Python 3. Okay, in my computer I have Python 3.8.1. In your Raspberry Pi, you have Python 3.5. Okay, but they are all Python 3. So for Python 3, actually, you can see if you use 84 divided by 10, you got 8.4. Okay, but if you use 84 double division, like double division sign, 10, you got 8. So that's what we call integer division. Okay, so integer division, that means it only return the quotient, which is an integer. Okay, so so sometimes when you need the integer, when you just need the quotient, you can use this integer division. Okay, and if you want to find the remainder, you can use the percent sign. The percent sign is for modulus. Okay, so you have the remainder. You see, 84 modulus 10, the remainder is 4, right? Because 84 divided by 10, the quotient is 8 here, and the remainder is 4. Okay. So you can see by using these two operators, you can get quotient, you can get remainder. Okay. This is very very useful. Actually, for example, if you want to buy something, for example, if you want to buy a machine, for example, okay, if you have $200 and that machine costs like $15 for each, and then you want to figure out how many machines you can purchase by using $200, you actually have to use integer division, right? Because you cannot do a real value division. If you do real value division, you cannot purchase a half machine, right? So you have to use integer division to figure out how many machines you can purchase using with the money in your hand. Okay, you have. Okay, and you want to figure out how much money you can left after you purchase that many machines. You can use the remainder. Okay, so this is the way that you can you can figure out by using this two operations. Okay, let me just use this. I don't want to play the PowerPoint, because that way give me too much. I have to switch between the slides and the program, and that actually cost me too much time. Okay, so let me just do this. Okay, so so we know if you want to do integer division in Python 3, you have to use this. Okay, in Python 3, actually, this is not integer division. It's just for general division. Okay, but for integer division, you have to understand integer division, the result is only the quotient. Okay, for example, this. If you do this in Python 2, the result is 1 instead of 1.56. Okay, because integer division, it only retains the integer part. Okay, And for modular, it gives us the remainder. You see that? All right. So for real numbers, actually, we already know this in C++, the same. In Python is the same. Okay, so this is a real number, and also this is a real number. It's expressed using scientific notation. So this means the value of this means 2.143 times 10 to the power of 17. Okay, so it's a pretty big value. These are the operators for calculation in for real numbers. It's the same as for integer values. Okay, but for real numbers, actually, if you want to do real numbers in Python 2, you have to use real numbers. You cannot use 15 over 2. If you use 15 over 2, the result will be integer 7. And that's the integer division. Otherwise, if you want to do a real number division in Python 2, you have to use 15.0 over 2.0. So that means, first of all, you have to convert your data from integer to real. Okay, so if you don't have this 0, it's an integer. If you do have this point 0, that's a real number. Okay, but again, in Python 3, you don't need to worry about this. Okay, in Python 3, even though you type in 15 over 2, it is still 7.5. Okay, so you don't need to worry about this in Python 3. Okay. For Python, actually, is very powerful. In fact, there are tons of packages. For C++, remember, whenever you want to use a library function, you have to use include, right? Include the library. For Python, it's the same. You can use library functions. There are tons of packages, libraries that you can use. Okay, so there are a lot of, because Python actually is a kind of open source a programming language. There are a lot of people, they are designing packages for Python to support Python. So, there are a lot of packages that you can use to help you do a lot of things. Okay? For example, for math, actually math is a system package. Okay, so but you still need to include the package into your program. So in Python, actually, instead of using include, you use import. Okay, so this means this line means from the math package, you import all the functions. Okay, star means all kind of functions. So you from the math package, you import all the functions. That means after you have this, you can have all these functions. You have ABS, that's absolute value. I don't know what happened. My computer is so slow. Let me see. Let me try to figure out what happened. Oh no, maybe it's the Zoom. Yeah. Okay. All right. So so for Python, actually, you can see we have all these functions. You have ABS, cell, seal. This C actually is the seeding function. I don't know whether you know what is seeding function. So seeding function actually means you get the so for example, if you have a seal 5.3, that means the seeding function returns a value of 6. Okay, so seeding function actually returns a value which is greater than the value in the seeding function, which is the smallest integer greater than the value of your seeding function. Okay, so that's for seeding function. And floor, that's the floor function. So floor function means round down. Seeding function means round up. Okay, so round up means the smallest integer which is greater than the value you are looking you have. Okay, and rounds down means the largest integer which is smaller than your value, than this value. Okay, so that's for floor operation. Okay. So you can see actually we have all kinds of math functions that we can use in Python. Is similar to what we have in C++. Okay. So in Python, actually, we do have variables, same as in C++. So if you want to assign a value to a variable, you just use, for example, in this case, x equal to 5. X is a variable, okay? So it's equal to 5. And same as in C++, each variable, the machine will assign a specific memory location. And when you assign a value to that memory location, you actually assign that value to, when you assign a value to a variable, basically you save that value into the specific memory location for that variable. Okay. All right. So first let's look at one example of a Python program. So for this Python program, actually, we want to evaluate the quadratic equation for a given ABC. So for example, if you have a quadratic equation, you may have like let's see. For quadratic equation, for example, you may have a x squared plus b x plus c equal to 0. If you have a quadratic equation like this, you can have two roots, right? Okay, so this is the that you can use to evaluate a quadratic equation. Okay. Right. So this is the formula that you can use to evaluate a quadratic equation. Okay. And by evaluating this quadratic equation, you can calculate for two roots. Okay. So let's write a program that we can evaluate a quadratic equation to find out the two roots. Okay. All right. So you can see this is the Python program that we can use to do this. We can use to evaluate a quadratic equation for a given value of a and b and c. Okay. So you can see, look at this program. First of all, you have to import all those math functions because we have to use those math functions, especially this square root. Okay. And then you want to let the user type in the values for A, B, C. Once you have the A, B, C values in your program, you can calculate for the two roots. X1 is negative b plus square root of b squared minus 4ac over 2 times a, right? And x2 is negative b minus. So once you have all the values, you want to output the message. You want to let the user know for this specific quadratic equation, the two roots are this. Okay, so we can run this program by typing. I mean, to get this, remember last time I already showed you how to open this editor. In fact, you use. I can show you. Let me show you. Okay. What you can do. This is the same as in Raspberry Pi. Okay. So in Raspberry Pi, but for me, I'm using Windows. But for your Raspberry Pi, remember you go to programming. So for my Windows, actually I go to Python, and you open the idle, the Python idle, okay, and then if you want to type in your program, you go to File, New File. Okay, so once you hit New File, you have this editor window. Okay, so in the editor window, you can type in your program like from, math, import, everything, something like that. Okay, so once you type in your full program like this, you can save your program using File, Save As. So you can choose your file program. Okay, so I already have the program. So I already have the program. So I don't need to save it. Okay, so but once you write the program, you can run it. To run your program, you can click run module. Okay, so once you run module, you have this window. So this window actually, you can see you have to type in the window for A. You see the A value of a quadratic equation. Let's just type in 2. Okay, and B value, let's use 4 for example, and C value is 1. You see the quadratic equation, 2 times x squared plus 4 times x plus 1 is equal to 0. That's the quadratic equation. So for this quadratic equation, the two roots are root 1 and root 2. Okay, that based on the root formula, right? The root formula, actually, which can be seen from this program. Okay, so you can see this is the way that you can write a Python program, and then you run the Python program. Okay, so this is for this exercise. Evaluate the quadratic equation. All right. So the next thing I want to introduce is the print function, the print instruction. Okay, so that's print is used to print out a string message. Okay, so the syntax is like this: you print a string, or you print a string expression. Okay, so so if item 1, item 2, item n, they are all strings, a text message, you can use this format to print a sequence of text messages. Okay, so for example, like this, you can print this. Okay, so you print, if you execute this, you will see you have 20 years until retirement, because age is 45. So 65 minus 45 is 20. So it will automatically combine this text message, this integer value, and this text message into one single sentence. Okay, and it will be printed out. Okay, so it's very powerful actually by using Python. Nowadays, actually, a lot of platform, especially for artificial intelligence research area, people use Python. The Python is very widely used by AI persons. Okay, and also for Raspberry Pi, most of people they use Python to program my Raspberry Pi. Okay. And we do have input. Actually, we already saw this input instruction in the previous example. Remember in the quadratic equation, we do have input here. Okay, the input actually is used to ask user to type in a text message. Okay, so for example here, when you ask the user to type in your name, so you're supposed to write a sentence to let user know what kind of value the user is supposed to type in. So in this case, if you run input how old are you, it's the console will display how old are you and waiting for you to type in something. Okay. In this case, actually, you're supposed to type in an integer number, but input instruction actually only read in the value as a text message. It won't convert your integer value into integer. Actually, it can consider it as a string. So if you want to convert your string into integer, you're supposed to use int or float. Float means you want to convert your string into float value, into real value. Okay. So in this case, if you do this, actually, let me do this. So for example, you can type in age equal to int input. Oh. Once you execute this, you see, it will ask you, how old are you? So that means it just output this line. This actually is used to prompt the user, let the user know what the user is supposed to do. Okay, so you can type in your age, like 25, for example. Then you see age now has a value of 25. Okay, because in fact you have this integer. Okay, so that means if you want to use if you want to input a integer value, you have to convert it, because the input function just read in a string, a text message. Okay, so that's very important. You have to understand. Okay? Another example for us to learn how to write Python actually is here we have another exercise. So you're supposed to write, here I just want to show you the examples. You can practice by yourself, okay? So this exercise is asking you to write a Python program that prompts the user for his or her amount of money, then reports how many Nintendo Wii's the person can afford and how much more money he or she will need to afford an additional Wii. Okay, so let me show you the program. So this is the program. You can see the first line asks you to input how much money you have, okay, and then it will ask you what is the price for Wii, and then it will tell you how many Wii's your money you can afford, and how much money you still need to afford to to purchase a additional Wii. Okay, so let's execute this by click run module. Do you see? It asks you how much money you have. Okay, so let's just choose 100, for example. And what is the price for Wii? Let's choose 45, for example. Okay, you can see you can afford 2 Wii's, and $35 are needed to afford an additional Wii. Because if you purchase 2 Wii's, you have only $10 left, right? If you want to purchase an additional Wii, you need to add $35 to afford another one. Okay, so you can see this actually is a very good example for calculate, for the integer division and the remainder. Okay, so this is the integer division. Use 100 integer division by 45. The quotient is 2, right? And the remainder is 10. So you use the V price minus the remainder, you got 35. Okay, so this actually is a very good example for using for integer division, and actually we can use integer division here. Okay. So let's do it again. We have 125. All right. So this is a very good example for you to practice integer division and modulus. Okay, so this is a very good practice. All right. All right. Okay, same as in C++, we have loops. We have also selection for Python. Okay. So for loops, first loop is for loop. It's very similar in C++, but the format is a little bit different. For loop in Python, actually, the syntax is like this: for variable name in a group of values. It's different for C++. For C++, remember, it's like for I equal to 0, and semicolon, I less than 10, semicolon, I plus plus. So that's the general syntax for loop. But for Python, actually, it's different. It's for variable name in group of values. Okay, so this is an example. You see here, this is one example. In this example, is for loop. And another interesting for Python, actually, in Python, we don't use curly brackets. For example, for C++, remember, we use curly brackets to include the programming block, right? For Python, actually, you use indent. Okay, so you see, use this to indicate that this is the for statements. Okay, so you have to make sure you understand this. Okay, so in this case, for x is the variable name in range. Range is a function. Okay, so range 1 to 6. The value of this range actually means from 1 but less than 6. Okay, so in this case, if you run the range function of this, the output is 1, 2, 3, 4, 5. Okay, so it should be less than the last value, the stop value. Okay, so it includes the start value, but exclude the stop value. Okay, so it should be 1, 2, 3, 4, 5. So if you run this for loop, you will see this output. Okay, 1 squared is 1, 2 squared is 4, 3 all the way to 5. You don't see 6, because 6 is the stop value, and stop value is excluded from the range. Okay, so this for loop means x equal to each individual values in this range. Okay, and in fact, we have a step value. Okay, so in here we don't include the step value here. That means the default step value is 1. Okay, you can choose another value. This is you use -1. That means it's from 5 all the way to 0. So 5 will be the start value, and 0 will be the stop value. Okay, the the step size is -1. So that means you go from 5, 4, 2, 3. I'm sorry. It's 5, 4, 3, 2, 1. Doesn't include 0. Okay. Remember, for range, actually the stop value will be excluded. Okay. So, so you can see if you run this program, because this print instruction is indented, that means this print instruction actually is inside of the for statement. Okay, but this one actually is outside. Okay, so you can see for Python actually you use indent to indicate whether it's inside of a for loop or if statement or not. Okay. This is an exercise that means we can use for loop to print 99 bottles of beer song. Okay, let me show you the program. So this is the 99 bottles of beer song. We can just use for loop. Okay, so the for loop is in range from 99 to 0, and the step size is -1. And so you just print out the song by using different I values. Okay, so actually, if you run this, you will have this is 99 bottles of beer. You see 99 bottles of beer on the wall, 99 bottles of beer. Take one down, pass it around 98 bottles of beer on the wall. So you can do this until it's equal to 0. Once it's equal to 0, then you see this normal bottles of beer on the wall. So this actually is the it's an example that you can use for loop to output this kind of information. Okay. We can have cumulative loops. So some loops incrementally compute a value that is initialized outside the loop. So this is sometimes called a cumulative sum. Okay. So you can see this actually, you have a sum value outside of the loop, and then inside of the loop is cumulative sum together, sum on certain values. Okay. So this actually example, it sees eventually print out the sum of the first 10 squares is this. Okay, so we can work on an exercise that we can write a Python program that computes the factorial of an integer. The factorial of integer, remember, you can do a multiplication start from 1, multiply 2, multiply 3, all the way to that specific number, and that will be the factorial number, factorial value for a given number, right? So if we want to calculate the factorial of integer, we can write a Python program using this kind of cumulative loops. Okay, so let's see. So this is you can see this is the program for cumulative cumulative loops to calculate for a factorial. So you can see, first of all, it will ask you to ask the user to input an integer value. So you're supposed to use int to convert this because input function just reading a string, right? A text message. And even though you type in a value, you type in an integer, in fact, computer or input function just consider that as a string. Okay? So you have to convert that string into integer by using an integer function. And once you read in the value of n, then you can use cumulative loops to calculate for the factorial. Okay, so the fact is equal to 1, then 1 times starting from 1 all the way to I, okay? All the way to fact, in fact, to n. Okay. Why I use n plus 1? Remember, the stock value actually is excluded, right? So you have to make sure that you multiply from 1 all the way to n. So you cannot use n here. If you use n here, then the range becomes 1 to n minus 1. Okay, so that's why I put n plus 1 here to make sure that the n is included in the range. Okay, so that way you can get the factorial, and then you print out the output. Okay, so let's run this. So when you run, you see input the value. So let's say input 10, for example. This is the factorial value. So factorial of 10 is this. Okay, so it's a really big value. Okay, so you can see this is the way that you can calculate for factorial of a given integer by using a cumulative loop. Okay. Any questions up to now? All right. So the next Python programming structure is the if statement. Okay. So if statement actually is very similar to the if statement in C++. Okay. So, I forgot. For loop, you see, you have to use a colon here to indicate, the remaining thing is the for statement. Okay. So same thing for if statement. You're supposed to have a colon here. Okay. So you have if condition, and then colon, and then statements. And you can have else. In fact, you can have else. Else and then statements. Okay, so same as in C++. Okay. So for example here, if GPA is equal to 3.4, if GPA is greater than 2.0, then print this. Otherwise, it doesn't print anything. Okay, so that's for if. And this if else, same thing as in C++. You have if condition else. So don't forget you have this colon here. Okay. So in this example, if GPA equal to 1.4, if GPA is greater than 2, then you print something. Else, you print some other things. Okay. So if you have more conditions, you can use if condition 1, else if condition 2, else, so it's very similar to C++. If you have C++ background, it's easy to understand these structures in Python. Okay? And while loop, same while condition. Don't forget the colon, and then you run the statement. Okay, so you see number equal to 1, while number less than 200, you print number. Okay, so you change the number. So for while loop, you have to update the value for the condition. And if you don't update the value for the condition, you will either never run the while statement, or you will have infinite while loop. Okay. For logic operations, it's also pretty similar to C++. You see, you have this double equal signs. That means you check whether two values are equal to each other. This means whether the two values are not equal to each other. Less than, greater than, less than or equal to, greater than or equal to. Okay, so it's very similar to C++. Okay, and also we have AND operation, OR operation, NOT operation. So it's different from C++. Remember, in C++, the AND operation actually you have double ampersand signs, and OR operation you have double bars. And NOT operation actually you have a tilde sign. But in Python, actually, you use the word, use and, use or not. Okay, so it's easier to understand. All right, so to understand this logical operation, you can work on this exercise. That means you write a code to display and count the factors of a number. So, for example, given a number, let's say 6, for example. So the factors for 6, actually, you have 1, 2, 3, and 6, right? So you have 4 uh, factors for this number. So for factors, that means the the we can say is the divisor for a given number. Okay, so you can find the display the factors and also the count of factors for a given number. Okay, so let's look at this example, and you can see from this example, this is the program that you can use to display the factors of a given value. So you're supposed to type in a value. The first line is used to ask the user to type in a value, and then you can use a while loop to calculate the factors and count how many factors we have. Okay, so to find out the characters, you have to make sure that your remainder, this n is the value you want to look at, and I is the uh, factor you want to check. Okay, if n modulus I is equal to 0, that means I is a factor, right? So otherwise, it's not a factor. Yes, that's why you use an if statement to find out. And the while statement actually is to make sure that you check every value starting from n, starting from 1 to n. Okay. So so if we run this program, for example, let's check the value of 36. So you can see the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, 36. Totally, 36 has 9 factors. Okay, so this is the program that you can use to calculate for factors and also a number of factors for a given integer. Okay, so this is an exercise that you can do to exercise how to write if statement, while statement, and how to use this logic operations. Okay, and the next topic I want to cover is text and file processing. So for text, Python actually is very powerful dealing with string operations or text operations. Okay. So for string, you see if you use double quote or single quote, that's a string message for Python. Okay, and a string can represent characters by preceding with this. So if you have this, it means a tab character. Okay, and this means new line character. This actually you see this in C++, right? If you want to output quotation mark, you have to do this. Okay, so if you don't put a backslash, that will be considered as a quotation for a text message. Okay, so you have to make sure that you use a backslash to output a quotation. Okay. If you want to output a backslash, you have to put a backslash in front of it to indicate that you want to output a backslash. Okay, so so this actually, if you want to print this message, you will see. Let me see. Okay. So for example, if you want to print this, you will see. Um, if you print this, you see you have a tab here, and here you have new line. Okay, that's, you see a \t is a tab, and \n is a new line. Okay, so the characters in a string, actually they are numbered with indices, starting at 0. So for example, if you have a string like this, when the Python program save this string into computer memory, it looks like this. Okay, so P as a character will be saved in the first location, and the index number for first location is 0. Okay? And then consequently, you save the dot character, the space, things like this. Okay, so for example, if you want to display only this character, you can use name brackets, and this value should be the index value. Okay, so if you want to output capital D, you have to use 3 as the index value. Okay, so that's for indices for string. Okay? So for string properties, you can you can output or return the length of a string by using len function. And you can use this string.lower to convert every single character in a string to lowercase letters. This upper function is used to convert every single character in a string to uppercase letters. Okay, so here are some examples. Okay, and input function, we already saw that, right? So the input function actually basically it reads in a string message, a text message. So you can, whenever you want to ask the user to type in something, to input a text message, you can use this input instruction. This is actually very convenient for programmers to make sure that your program is an interactive program. Okay? And for text processing, you see, you can use a for loop. So for C is a character in this string. So this basically, actually, it will, the C will equal to B and print C, so print B. And then C will be equal to O, and print O. So eventually, it print every single character in this string. Okay, so you can use a for loop. So you see, in Python actually is very powerful comparing to other programming languages. And this actually give us another two functions that we can use. ORD actually is to convert a string into a number. This number actually is an ASCII number. Okay. This CHR, it will convert a ASCII number into a string. Okay. So what does the ASCII number mean? In fact, let me show you. So you see, there is a ASCII code number. ASCII code. So the ASCII code actually, the ASCII code, remember, computer only understand binaries. Okay, so that means if we want to save a string into a computer, if we don't do something, it's impossible, because computer can only understand 0, 1. It doesn't. It's impossible for computer to understand the character of A, B, C, D, E. So how can we deal with this? In fact, the researchers actually design an ASCII ASCII table. Okay, so this ASCII table, this is the ASCII table. So the original ASCII table actually convert a code into binary. Okay, for example, here, small letter A. Small letter A, we have the row number is 6, and let me see. Okay, yeah, the first three first three binary values is 110. 110 actually in hexadecimal is 6. Okay, and then the next four binary values for A is 001. Okay, so you have 110 and 0001. Okay. So this actually is in hexadecimal. So in hexadecimal it's 6 1 for A. If you convert hexadecimal from 6 1 into a decimal, that will be the value of 97. Okay, so 661 in hexadecimal convert to decimal is 97. Let me show you. Okay, so hexadecimal 6-1 in decimal, you see, is 97, right? Okay, okay. So so you can see if you use ORD to convert character A, it's 97. So this function is to convert a character from ASCII from a character into ASCII number. Okay, so if you want to convert an ASCII number into a character, you use a CHR function. So this is very these are two very useful functions that we can use to convert a character into ASCII code and or convert ASCII code back to character. Okay, so here we have one exercise that we can work on this exercise on these two functions. Okay, so this exercise is asks you to write a program that performs a rotation cipher. Okay, so that means, for example, this is the if attack is an input text message, when rotated by one rotation cipher, it becomes BDL. Okay, that means A becomes B, T becomes U, T becomes U, A becomes B, and C becomes D, K becomes L. Okay, you see, you replace each character by using the character to its right by one location, right? So B is the letter to the right of A by one location, right? So you rotate by one. Okay. So you want to write a program that asks the user type in a string and also the number for rotation, okay, and then you output the result. Okay, so let me show you the program I have. So you can see, first of all, you ask the user to type in the string you want to do the rotation cipher, and then you want to ask the user to type in how many characters you want to rotate. 1, 2, 3, you know, and then first of all, you have to define a output text. Okay, so output text initially is an empty text. Okay, and then you want to convert each character into, you see, into first of all, you use ORD to convert that character into ASCII code, and then you add onto this value the value you want to rotate, how many characters you want to rotate. Okay, and then convert the result back to ASCII. Get back to character. Okay, and then you add this, concatenate this onto the output text. Okay, one by one. Okay. So eventually, you can output the cipher, the rotation cipher text. Okay, so if we execute this program, you can see at first you type in the message. Let's just use attack and rotation by 1. So you see the output is BUU VDL. So it's BUU VDL. Okay, so if we can do this again by using a different value of rotation. For example, for 3, so it becomes DWWDFN. Okay, so you see, this actually is a very simple method that you can create, a password to make this password actually other people doesn't know what it is. Okay. All right. So let's just stop here. Do you have any questions?
Can I ask you a question after class?
Yeah, go ahead.
Project.
For the project?
Yes.
Okay. Yeah, you can. I mean, you can ask right now.